Well, good morning, ladies and gentlemen. Today we're going to show you how we put in a radiant slab under our hangar row. And here is the grass at Butler County Airport, KHAO, Hogan Field. And this is where T11 is going to be. And there you see all the grass that was right there. It was just a place they were using for parking. And then we rented it. And our process is going to be, we're going to level it all out. We're going to put down rock layer, get that nice and level. Then we're going to come down and put insulation, and as you can see it there, it's 2 inches of blue cell foam. These are 2x4 sheets, and they are 4 feet long, and they interlock. These are seconds from a building restoration company, but anyway, they're going to be our 2 inches of base that's going to separate our slab from the ground. The concrete side's going to go down, and then we're going to have 2 inches of blue foam. Then on top of that, it's going to go 5.5 inches of concrete. And that concrete's going to have rebar, and it's going to have 3/4 inch PEX tubing running through it. Now, there are 5 hangar bays that are going to be in hangar T11, and each of them is going to have a radiant floor. Now, they're all going to be independent radiant floors, so each bay will control its own radiant floor. But again, the whole building is going to have radiant heating on the floor. And I got to tell you right now, it's pretty nice to have. But anyway, here's all the insulation being stacked and scheduled, ready to go. And then here's the day that the building arrived on the trucks, and we had to unload it. And it was quite a bit of steel and quite a bit of metal and everything to have it all there. As you can see, we have a pile there, and then there are 2 trucks still waiting to be unloaded with the forklift. But anyway, that was the building coming in, and then there's going to be a bunch of pictures as we start the construction process of preparing the ground. It basically falls down as follows. To get the ground, we're going to take away all the grass and get down to the dirt that we want and get a level that we want. Then we're going to get it all leveled in the dirt. Then we're going to have to come in and we're going to have to dig the pylons where the building is going to be supported down the ground. These are normally 10 feet by 10 feet and 2 feet thick, and they're 4 feet down in the ground. We're going to put in the pylons. Once the pylons are in, then we're going to survey out and we're going to put in the storm water system. We're going to have French drains on by the door side, and as you can see here, we've already marked the grass. We're going to put in storm drains. We're also going to have sewer and water brought in for each of them, and then eventually natural gas will come in to provide the power for the radiant floor. But here's the equipment. As you can see, the building's all lined up along the taxiway there, along with all the styrofoam that we're going to use. And then the equipment is going to first get us a nice level dirt. This was all done with laser levels, by the way, the final thing. And the dirt was all taken away on purpose for some of the low spots that we have on the airport. But as you can see, it's just takes a lot of time. I'm going to let you enjoy these pictures for a few minutes, and then I'll be back to talk to you some more about some of the other processes that we went through. Now, as you can see, we're down to the dirt is level where we like it, and we've already put in our paint marker lines. This is where the storm drains are going to go, the edge of the slabs are going to go, and at this point, they're positioning and digging the beginning of the pylons that we have to put down. And since the building has I think it has 5 major or 6 major arches, there are going to be 12 pylons, one on the east side, one on the west side. And you can see the pylons are all marked out with the orange paint in the dirt. And then they just basically, they dig them all down to spec. Then they start building up the rebar that's going to go into them, and then when we have a concrete pour, we're going to pour all the pylons, and then we can start on the plumbing. And when the plumbing's all done, then we're going to pour the slabs on the building. Now when the slabs get poured, we don't pour the whole thing as one uniform slab, so that we can level it and keep control of it. We're going to do the first 100 feet, then we're going to do Bay Charlie, the middle section, the middle 50 feet. The into sections are 100 feet. You can see the pylon holes right there in the ground. And then we're going to finally pour Bay Bravo, which had a different insulation system for snap-in, but it was, again, a radiant floor system. And then Bay Alpha, which is the 80-foot bay, we're going to pour it last. And as you see, I'll let you watch as we do all these, but here are the pylons going in and the concrete and the rebar all getting set, and we really feel like we're making progress at this point. Now we begin the process of putting in on the backside, the west side of the hangar, all the sewer and the water lines, as well as the sewer clean out lines. Every bay will get one of those, as well as having city water brought to all of the bays. And as you can see, we have the stand-up pipes there for each of the systems that are going in. Now Bay Alpha has 2 bathrooms put in. Each of the other bays are just plumbed for 1 bathroom. And again, there's the bathroom drain out in each one. And then eventually we will have a French storm drain. We'll have 12 feet of that leveled down on the hangar floor, so that any water spilled in the hangar will migrate towards the French drain up by the door. And it's 12 feet back from the door and 12 feet long. And that way, if you want in the winter, you can wash your airplane and stay nice and toasty and warm. And as you can see here, here's the storm drain going in. It's a completely different system from the sewer drain. And you can see the sewer standout cleanups all standing up there, independent of the row along the back of the hangar where most people chose to have their bathrooms. And Bay Bravo has a bathroom downstairs and one upstairs. Now that we have all the plumbing in place, now comes the problem of now we have to re-level everything over the pylons or where everything's sticking up, and we did. Then we brought in 2 inches of number 2 crushed limestone, and then on top of this, once it's all leveled and laser leveled and pressed down, and we're going to let it weather for a week or 2 in the rain and all in the springtime. Now we're going to go ahead and begin putting the insulation down, and then on top of that the concrete will go. So stay tuned for more of this action. And as you can see here, here is Bay Echo and then eventually Bay, this is Delta and Echo, the north 100 feet being poured with concrete. That was our first pour. And then we did, here you can see what it looks like. They put their radiant floor systems together against the common wall. And then we did Bay Charlie, which again was a blue foam one, and as you can see all the yellow insulation there, that is going to be Bay Bravo, and then those piles are going to be in the foreground, are going to be where we're going to insulate for Bay Alpha. So this is what it's like. We're pouring down the concrete after the PEX tubing is all in place. Now here is Bay Alpha, here is Bay Charlie. And as you can see, this is all the PEX tubing for Bay Charlie being laid out, and you can see Bay Bravo to the left there. Again, they all have their own independent radiant floor systems. It's kind of nice. For about $1,000 a year in natural gas in the 2023-2024 pricing, you're going to have a warm hangar 24/7. And then here's the insulation going down for Bay Alpha. All the other bays have been poured, so there's 200 feet of concrete curing up away from you in the background. And then once it's all done, then we're going to go and we're going to throw the steel up, and then once the steel is all up and secured and anchored and leveled and all the other stuff you do with the steel going up, then we're going to skin it, and then at that point we'll be waiting on the doors and everything. But as you can see here, we had a snow one day, and with the radiant floor, where the radiant floor and the radiant ramp were, and here's the radiant ramp going in, that way we don't have to shovel snow if it goes and snows. But we had a snowfall, and where we had the insulated concrete for the radiating portion, you notice that we still have snow on the slab and the radiant ramp. Everything else has gone away. That's because we're well insulated from the ground. So once that concrete gets cold, it will stay cold. Once it gets warm, it will stay warm. So stay tuned for some more fun. Well, good morning, ladies and gentlemen, and welcome to Growing Pilots YouTube channel. And today we're going to talk about the radiant floor and our hanger floor system. And basically, it's a bunch of PEX tubing put down before the concrete was put into place. And let's talk about the first component, the PEX loops. Now, Matt and I laid this down in 2016, right before heading down to Bowling Green. And there are 4,300 feet in the main hangar, which constitutes 11 loops around. Now we have 2 that run around the outside corner, and what they do is they provide the heat to the outside where it loses it to the rest of the world. And then we have a bunch of main loops in the field that are not quite tightly lit. And then of course we also put down PEX tubing to have a radiant ramp. It's 25 feet by 50 feet so that we can melt snow if we want to, that way we don't have to go out and shovel it. Now, we designed our system based upon the HydroSmart diagram that came with our boiler. So we laid out a manifold board, and this was going to corral all the PEX tubing into the manifold, both the supply and the return lines. So there's 26 pieces of PEX and 13 loops. The 2 on the right are for the radiant ramp. Now let's talk about the rest of the system. As the manifold board is being laid out, we get water from the hot water heater. It comes in, it goes by an expansion tank, it goes to a pump, which blows it around into the floor. Return pump pulls it back out of the floor. And when we got it all put together with the Y strainer, we did a pressure test. And it was during the pressure test that we found out we had a little bit of a problem. We had 4 leaks. And that was because the 1-inch pipe was BSP on one end and NPT on the other.
So this is the air eliminator. Now this one has sweat fittings on it, and it weighs about 3 pounds. It's out of cast brass, and on the inside you have a bunch of stainless steel and a valve that gets the micro bubbles as the flow unturbulent goes through it. Now it's easy enough to look inside, and as you can see there's some stainless steel wire screening inside the valve, inside the air separator, and that's what drives the micro bubbles out. And it's all spiraled up in there, and they come out, and there's a valve at the top to eliminate the air. So this is how you purge the air from the system to get all the bubbles out. So all you have is 99.6% solution and only 0.04% dissolved air.
So here's the system getting ready to go into pressure testing. There's no air eliminator and no pressure valve during the pressure test, but everything's all put up. We're going to work on the electrical wiring here, but we're about ready to turn everything on and have the hot water heater start sending things over. But first we have to do the pressure test, and then we'll load it with the antifreeze mix. And that's pretty much how everything went. Now here's the hot water heater. It's natural gas, 120,000 BTU unit. It is modulating, so it will change how much. So we can start water as low as 100 degrees and take it up to 160. It will do 7 gallons a minute. We have pressure gauges in the system, a Y strainer for taking debris out, the air eliminator to get all the bubbles out, and we have both the input and output pressure and temperature so we can see what's coming into the system and what's coming out as we heat the floor. So here's an example of one of the little pressure gauges that we have in the system. It's right there in the 1-inch copper pipe. We have isolator valves around the Y strainer. We have isolator valves around both of the motors so that if anything ever happens to them and they have to be changed out, it's not an issue. And there's the pump for the primary loop, and then that goes down into a mixing valve where we can mix the water. Here's our air expansion tank, all hooked in, and there's the isolation valve, and here's the manifold for the radiant ramp, and we're having a leak test here, and we're having a few issues that we're going to address. There were 4 leaks in the system, and they were where the manifolds were connected together with the connecting nipples, and that's because the nipples were 1-inch MBT threads and the manifolds are 1-inch BSP threads, and we could never get it to seal, so we welded it with stainless steel piping, and not going to be an issue anymore. So here's the final layout after the final pressure test. We just pan through all the components. There's the air eliminator all installed in the 1-inch and turn line. There's our pressure regulator, and it draws down into an overflow bucket, so if we ever get any pressure, the antifreeze will go into a catch bucket. Isolation valves and pump, our mixing valve right there, and down into the overflow bucket. So now the system's all ready to go. We've got it loaded now with antifreeze, and it's time to turn it on. Well, we turned the system on and it started running, and we started using gas out of our gas line. But to make sure that we could track what was going on with the system and heating everything, we installed a camera on the board so we could watch the air temperature on the bottom left there and the return temperature. And that's what we studied for the next 3 days until the system began to cycle, knowing that they're letting us know that the concrete floor, 500,000 pounds, was up to final temperature of 68 degrees with a start at 43. And not only did we watch the return temperature rise, but we watched the air temperature 3 feet off the floor come up as the floor was being heated. And it came all the way up, and now the system is cycling normally. We've taken our Perfect Prime infrared camera and we can see where the concrete is cool and where the loops are. And we were checking all of that. We finally came around to where we found the big thermal mass, and that was where the manifold, where the 26 lines enter and exit the slab. That piece of concrete is really nice and warm, and that's where we have all the sofas and the recliners so that you can sit someplace nice and warm. So here we are looking at the hot water heater. In our case, it's natural gas. It's a 13,000 to 120,000 BTUs per hour. It's a modulating hot water heater, so it'll give us what we need, up to 7 gallons a minute. And then there's an isolation valve on the tank, and then we talk about system components very quickly. And then here's our air expansion tank, which is our pressure tank to grab the pressure ripples out of the system when the motors start up and shut down. There's our air separator and our overflow bucket so we can catch our expensive antifreeze water glycol mix back. Our primary pump is 125 horsepower, mainly drives the big loop, sets up the pressure, creates low pressure for the air separator, a mixing valve so that our input and our primary system and secondary system do not have to be at the same temperature. And then that's the line for refilling any volume we're missing. We had to do that a couple times the first couple of days. Here's our supply manifold. The two on the right are for the ramp. and the other ones, or the 11, are for the main field of the hangar. And then we go up into the return side of the manifold, and we have a pump which pulls water out of the floor and goes through an isolation valve and then comes back into the mixing valve.
So here's the gauge on the side. It's 0.2 to 1 gallon per minute, and liters per minute 1 to 5. 0.05, 1, 2, 3, 4, 5, and in gallons per minute 0.02 to 1.3 at the max. Turn line back through the secondary system pump, back to the mixing valve, back through the Y strainer to collect any sediment or trash, and back on out. Now the things to notice around the pump: the Y strainers are isolation valves, so in the future, if anyone ever needs to be changed, then they're right there ready to go. And the mixing valve is set right now for one big primary loop, and we can mix it partially if we want to run our primary loop at one temperature and our secondary loop at another, but we're running everything at one time, and we have the 2 pressure gauges in the system for both supply and return pressure, as well as a 1/25 horsepower primary pump and a 1/6 horsepower pump for the secondary loop to push the 3300. Well, that's the radiant system we're using to heat the floor. It's a simple system. We hope you found all this useful and informative. Thanks for watching, and have a good day flying your Grumman. And in addition, as a little treat, about 3 o'clock in the morning when I'm doing web work and other stuff, here's my cat coming down, playing with a mouse and meowing and just having a good time with me in the wee hours of the night. So I thought I would throw this into you as a little treat. Y'all please enjoy.